Okay, I'm going to start the class because many of the students are not facing any problem of echo. Please check at your end for the echo. Okay, so let's start. First of all, many of the students are asking for analog circuit. Sir, do we require electronic devices? So I would like to confirm that no electronic devices is required for analog circuit that much. Okay, no doubt some concept of the analog electronic devices will be used in the analog electronics, but not that much. Meaning is that if someone is not comfortable in electronic devices also, then that student can also understand analog circuit, because you know very well analog circuit is also for electrical engineering student, and electrical engineering student do not have electronic devices in their syllabus. Then the question is how they understand the analog circuit. Really, they understand the analog circuit in a well manner. So what we have to do is, electronic devices is something different subject, just think like that, and analog circuit is something different. So I want to clear the difference between electronic devices and analog circuit. In electronic devices, you understand what is going on inside the device, how current is flowing, what is the equation of current, how this current came into the picture, what is the electrostatics, how potential is varying inside the diode, BJT, MOSFET. Okay, that is happening in the electronic devices. Okay, so everyone is having different issue. One student is saying, sir, mic volume increase कीजिए, please increase mic volume. Someone is saying some different opinion. Then how I can resolve it now? Okay, so now the point is, in the electronic devices that things we study. Okay, but in the analog circuit it is completely a your application subject. Okay, application subject means here you will have the application of the devices, how diode can be used in the circuits, how BJT can be used in the circuit, how MOSFET can be used in the circuit, and this is the analog circuit. Okay, no doubt for the analog circuit, network analysis is must. Network analysis is the must subject for the analog circuit. That's why your network analysis subject is also running parallel to analog circuit. And along with that, in the analog circuit itself, whenever some concept from network analysis is coming, I would like to tell you. Okay, I will tell you definitely about that network concept that is going to use, but you have to accept that concept very quickly. I will not give that much of time of the network analysis. Okay, in the separate subject you will be dealing the concept in a detailed manner for the network analysis. So let's start the analog circuit. Okay, I hope now everything will be fine for you. Okay, so let's start the subject. Okay, before going to start the subject, I want to clear few points. From starting to end of this subject, you have to listen subject very carefully, and after listening this subject carefully, what I can give you, I can give you a complete 100% confidence about this subject. Whenever you will go, either in the interview, either in any IIT interview or engineering services interview or any other interview, you will rock 100%. You will rock. Along with that, if you go for the higher studies, at that time you will not feel any difficulty in this subject. So this is your one-stop solution. After listening this subject completely and following all the instruction, you need not require to follow any other source. Any other source you do not require to follow. This is your one-stop solution, full and final. And whatever written on the board will be the final answer, will be the final concept. No need to worry about anything. Okay. If you find something different than this at any other place, don't believe on that. Okay, it is full and final. All the research content, all the experience content you will be getting. Okay, so let's start the first lecture of this diode circuit. Okay, so before going to start the subject, okay, I will tell you what is the syllabus of analog circuit. So this is the gate class. Definitely I would like to introduce the syllabus of the gate, okay, for electronics branch student and as well as for electrical branch student. So a brief syllabus is, the first topic in the syllabus is your diode circuit. Okay, first is your diode circuits. Diode circuits. Okay, and we will start this diode circuit today itself. Okay, second is okay, second is BJT, bipolar junction transistor. Bipolar junction transistor, BJT. So what we will study in the BJT? BJT DC analysis and BJT AC analysis. You need not to worry about the syllabus. Whenever we are discussing the BJT, complete portion will be covered. Okay, complete thing will be covered. Every point, every aspect of the BJT will be discussed in that particular topic. Okay, third is MOSFET. So similar to BJT, in the MOSFET also we will discuss MOSFET DC analysis, MOSFET AC analysis, and you have to focus on that. In your syllabus, a small signal model is mentioned, not large signal model. So you have to study a small signal model of the BJT, a small signal model of the MOSFET, a small signal model of the diode, that we will discuss. Okay. Fourth one is op-amp, operational amplifier. Fifth topic is, so we have covered all the great amplifiers like BJT, MOSFET, op-amp, and that is diode circuit. And then we will have feedback amplifier and oscillator circuit and oscillators. Feedback amplifier and oscillators, that we will discuss. And sixth special topic that I am teaching since I started teaching analog circuit, okay, that is CMOS inverter. And frequently many questions are asked in the previous examination, previous gate paper from this topic, that is CMOS inverter. Okay, so everywhere you will get the CMOS inverter. Just think like that it is from the kamesh notes only. Okay, CMOS inverter. So this is your complete analog circuit syllabus in topics name only. Brief inside the topic, what are the further topics are there, that we will discuss in the lecture itself. No need to worry or no need to spend too much time on the syllabus only. Now today we are starting the diode circuits. So in the diode circuit, what we will discuss? First topic that we will discuss in the diode circuit is diode circuit with respect to DC. We will discuss those circuit where diode is present in the circuit and some DC sources are present, DC current source, DC voltage source. So that first topic is diode and DC network, we can say, or diode with respect to DC. This is the first topic that we will discuss. Okay, diode with respect to DC. Second diode with respect to DC. Now second discussion is, after that, Clipper circuit means what you will see in the circuit, that I will tell you when I am discussing the Clipper circuit. But what you will see in the Clipper circuit, one big AC signal is there, large signal is there, and diode is there. Then you will come to know that this is the Clipper circuit. So Clipper circuit. Next, third one is clamper circuit, where you will find diode, some sources like DC voltage source, current source, and along with that you will be having capacitor, and that circuit is clamper circuit. We will identify the circuit, we will discuss, we will do the analysis of that circuit. Fourth one is DC power supply design. That we will discuss. In this DC power supply design, we will having subtopic, we can say. So how DC power supply is going to be designed? Like you are having some AC source, AC power inside your home. Okay, like for example, this is your charger. Okay, this is your mobile charger. Okay, so this mobile charger pin that you will plug in inside the AC source. Okay, and at this side what you get, some 5-volt DC. Okay, so this adapter will be having some circuit inside it, that is converting this AC power into equivalent into some required value of DC. Okay, like 5-volt, whatever you want, 4-volt, 6-volt, like that. So inside this you are having circuit, and that circuit is nothing but that we will discuss in a great level. Okay, with proper picture, proper understanding, just like a movie only. Okay, this subject is completely moving. Okay, so you will be having some rectifier circuit. After rectifier circuit, the output of the rectifier, okay, You will pass on, no doubt, before rectifier you will be having some transformer, no doubt. Okay, so transformer is not our topic. Transformer is not our topic, because transformer works is to step down the signal. Okay, so that is electrical branch. Okay, so transformer is not in our syllabus. So rectifier, so after transformer we will having the rectifier. After rectifier you will be having some filter, low pass filter, and then you will be having some voltage regulator, that is Zener voltage regulator. So don't worry about it, sir. What is the function of all these stuffs? We will discuss later, no doubt. One by one, everything will be cleared. Okay. So voltage regulator. If I am standing in front of you, just forget about everything. Just forget. Just surrender yourself and forget it. It's my responsibility to make you champion in the analog circuit. It's my responsibility, and I am completely responsible for everything. Okay. So voltage regulator. Voltage regulator. Okay. So specifically Zener voltage regulator, that we will discuss, no doubt. And fifth topic we will discussing over here is a small signal model. A small signal model of diode. A small signal model of diode. Okay. Okay. So let's start the discussion. So before going to start the diode circuit and everything, okay, what I will do is some basic idea about the network theory. So in complete subject, whenever it is required, I will tell you some concept of the network. Okay. So here we are not completing network analysis, we are going to complete your analog circuit, but whatever concept of the network analysis are coming into the lecture, that I will tell you. Okay. So some few concepts we can discuss over here. For network analysis, one of the concept is voltage division and current division. Okay, you should know current division rule and voltage division rule. Suppose in a network you are having some current. Okay, suppose this is a current source. Okay, this is your current source. Its current is I. Suppose for example I will have some number. Okay, because it will give you a better idea. You are having two resistors in parallel, like that. Two resistors. Suppose this is 5 ohm resistor. Suppose this is 5 ohm resistor. Just I am giving the name. This is R1 and this is R2. The current flowing in the R1 will be I1. Obviously, some current I is coming from here. Definitely, it will get divided into two branches because two paths are there. Current always flows in path. Okay, so this is one resistive path. This is another resistive path. Definitely, a total current which is coming from current source will be divided into these two resistors, and we will be having current I1 and I2. Now the concept question is, what is the equation or how to calculate this I2 current and how to calculate this I1 current? What is the rule? Suppose this is R1, this is R2 and this is current I. In a generalized way, what is the equation for current I1? I1 will be equal to, how much total current is coming? Total current is I into opposite resistance. You are finding current I1 in the R1 branch or R1 resistance. Opposite to R1 we are having R2. The formula is current in R1 resistance, that is I1, is equal to total current I into this resistance, that is R2, divided by total resistance R1 plus R2. R1 plus R2. So this is your current I1 in this resistor R1. Similarly, what is the current in this resistance I2? You need to remember this formula, okay, and understand this formula, okay. So I2 will be equal to current I into R1 upon R1 plus R2. So these are the two formulas for I1 and I2. Okay, I1 and I2. Fine. Okay. So this is your current division rule. How current is divided. How, I don't know how my problem is occurring, because Just before few days, I have completed advanced electronics and everything was fine. But suddenly, how it get disturbed? I don't know. How to check mic? Let me check. Open the mic. Okay. Why it is breaking? Now let me know. Actually, nothing had changed. Everything was fine. Only one thing I did in this class in the earlier, in the starting, like that only. But that I changed from the advanced electronics to analog circuit. Like that, I have put the mic, and this mic got disturbed. I don't know why. Okay, so okay, so let me connect the team once again. अब वॉइस में प्रॉब्लम आ रहा है, स्टूडेंट्स आर सेइंग। मतलब वो इको का प्रॉब्लम पता नहीं क्यों आ रहा है, जबकि सेम सेम आपकी सेटिंग है, वही एडवांस इलेक्ट्रॉनिक्स ऑलरेडी ले चुके हैं हम। तो लेकिन सेटिंग तो वही था, पूरा का पूरा ही था, वही सेम ही है ना, पहले वाला सेटिंग है सब कुछ। अरे फिर क्या करें, मतलब क्लास का क्या करें फिर, मतलब बच्चों को ज्यादा डिस्टरबेंस हो रहा है। अच्छा, और भी क्लास में है क्या? नहीं तो एक बार माइक में मैं मतलब वो सेट करूं कि डेसिबल मान लो 0 से मैं -10 करूं। अच्छा, फिर दिक्कत आ कैसे गई मुझे तो अभी तक समझ में ही नहीं आया ये। ओके ओके ठीक है। तो फिर बच्चों को क्या बोलूं मैं? बच्चों को तो वही बोलना पड़ेगा फिर कि एडजस्ट करो आज फिर। ठीक है ठीक है। अच्छा अच्छा। ओके। हम्म। ओके। ठीक है ठीक है ठीक है। ओके। Okay, so let's start the discussion. Now, my request to all of you is, if a small problem is there, please manage for today class, because from tomorrow class is also in the morning. Okay, so before the class, tomorrow class, we will try to rectify this problem. What is going on? Okay, I am having another mic also. Two systems are there. Okay, no problem. We can change. It is new mic only. Packed mic is only. Okay, so we will try to rectify all this problem, okay, before the class, but try to manage this class today, okay, because otherwise this class will be getting disturbed. Okay, mic is not working. See, देखो, those who are interested in changing of time, I am telling you, this is not in my hand. Okay, please do not message again and again about this in the class. If you want change of the class, you can message these things in the separately through telegram also. Okay, that is not a problem. Be mature. Okay, timings is not possible in the favor of all the students, because some students wants in the evening, some wants in the morning, some wants in the afternoon, some wants in the night, then it is not possible, and unnecessarily this disturbs the class. Okay, and this is the first class, and you have to understand that whenever a teacher is teaching in the first class, you can give a better response, okay, in the form of like not disturbing these types of with these types of messages, because already this class is disturbed too much because of this mic issues or voice issues. Okay, So otherwise either I have to end the class, okay, or we can continue the class. So it's your choice right now, okay. So please tell me, because some students are saying fine, because they do not believe in some small disturbances, okay, they can manage for one class. Okay, if you are not able to manage, you are not able to tolerate that mic issue or anything issue, okay, that is not in my control also, okay. I am here for my subject only, I can teach that subject in the well manner, okay. So in that case, we have to either stop the class or continue the class. Now it's your choice, I'm giving you the time, please message, okay. Okay, and for the class timing, again I'm saying please do not message about it, because it is not in my hand, okay, and I do not decide the timing of the class. So for that you can choose the proper channel, or you can message me on the Telegram. I can pass the message. If everything is fine, then it can get changed, because some students are interested in some other time, some are interested in some other time, okay. So try to understand, okay, right now, okay. So this is current division rule, okay. So according to current division, you can divide the current. If suppose you want to calculate this in the number format, you can convert it into the number format, okay. So in the numbers, what is the answer for I1? So this is the I1 current. I1 equal to, how much current is coming? 5 ampere, multiply by what is the opposite resistance R2, that is 5, upon 5 plus 5. Just I have taken same number, 5 ohm, 5 ohm. You can take some different number also, okay. So you will be having how much answer? So this is your 1 by 2, that is 2.5 or 2.5 ampere. In the similar manner, if you calculate for I2, I2 will also come equal to 2.5 ampere. So number is not important. Important is the concept, how current is dividing. I1 is I into R2 upon R1 plus R2. This is your current division rule, okay. Now what about the voltage division rule? Now let us understand the voltage division. So voltage division occurs in the series element, okay. So in the parallel you will be having current division. In the series you will be having voltage division. Suppose you are having some voltage like that, okay. Suppose some voltage like that you are having. Suppose this is a voltage V. You can have some number also, no problem, okay. So this is your some resistance R1, and after that you are having some resistance R2, okay. So no doubt this is your ground, and this is your R1, this is your R2. This is very interesting, okay. Now you have to calculate voltage across R1 and voltage across R2, okay. Voltage across R1 and voltage across R2, okay. So voltage across R1, some name we can give VR1, and voltage across R2 we can give the name VR2, okay. Now what is the voltage division rule? Okay, I am directly writing the equation, because you will know all the concept why this equation came into existence from network analysis only, okay. Whatever we will use in the analog circuit, that I am going to tell you directly, okay. So voltage across this R1, voltage across this R2, okay. Voltage across this R1 is V into R1 upon R1 plus R2. So right now VR1 is voltage across R1, total voltage, complete voltage in this circuit is, because this R1 R2 are in the series, complete voltage is V. Voltage across R1 is V into, in the current division we were multiplying with the opposite resistance, but in the voltage division V is multiplied with the same resistance across which we are going to calculate the VR1, okay. So VR1 is V into R1 upon R1 plus R2, okay. Next is VR2. VR2 is equal to V into R2 upon R1 plus R2, okay. Okay, so VR1 is V into R1 upon R1 plus R2, and VR2 is total voltage V into R2 upon R1 plus R2. This is voltage division. Now the interesting thing is, if I redraw this circuit, because this is your ground, every voltage in this world is with respect to ground only. So this is ground, so this node is ground. With respect to ground, this node voltage is V. Can I redraw it? If I redraw it, it is like this, okay. This is R1, this is your R2, okay. This voltage is some V voltage, and this voltage is some 0 volt, okay. Here V volt, and this is 0 volt. This is R1, this is R2. Suppose I want to calculate this node voltage. What is the meaning of node voltage? any node voltage is with respect to ground. Where is ground? Ground we are having over here. With respect to ground, what is the voltage of this node? That is nothing but VR2 only. So this node voltage, suppose I am calling this node as VP. Okay, VP. What is the meaning of VP? VP is the node voltage with respect to ground. Always try to speak in the network analysis, node voltage with respect to ground, this voltage with respect to ground. Okay, so node voltage with respect to ground. So what is this node voltage with respect to ground? Okay, so this node voltage with respect to ground is nothing but VR2 that we have calculated already. VR2 is the voltage across R2, here positive, here negative. So BP is nothing but VR2, VP, or we can say VR2, both are similar thing. And VR2 is equal to V into R2 upon R1 plus R2, right? This is the equation. Now the interesting thing is, suppose in this case we are having only V voltage over here and here we are having ground. Suppose we are having two voltages. Suppose one voltage over here and one voltage over here. Both the side you are having the voltage, and then I asked you what is the voltage at this node. Okay, so you have to use superposition theorem. So what is superposition right now? Okay, so next is third is superposition, so that I can tell you that question and that concept will be used again and again in the network analysis. Okay, or specifically in the today's class I will be using that concept. Okay, now the question is superposition. What superposition says? Suppose for example this is your resistor. Okay, this is your resistor. Suppose here voltage is suppose some 3 volt. Okay, and here some voltage is suppose 5 volt. Very simple. Okay, and this is your resistor R. Suppose I am asking you what is the voltage across this resistor R. Suppose simple, what is the voltage across this resistor R? This is a simple question, very simple question, no doubt. This is ground. What is the voltage across resistor? So everyone can give the answer very quickly because you are very comfortable in the network analysis. This is 3 volt, this is 5 volt. 3 minus 5 is minus 2 volt. Okay, or we can say this 5 is greater than 3, so this 5 will be having more effect, so this voltage will be, or by application of KVL you can get the answer very easily. Okay, but I am telling you I am not interested in KVL right now. Suppose I want to give the answer of this question based on superposition theorem. Suppose two sources are there. First I will find the answer of voltage across resistor with the help of this 3 volt and with the help of 5 volt. Suppose superposition. No doubt everyone is giving the correct answer like minus 2, minus 2. Two of the students have given this answer. Okay. Okay. So now the concept is we can use superposition also, because that is useful. Because suppose if you are having this type of structure, here some voltage is V1, here some voltage is V2, then we have to use the superposition theorem. So that's why I am interested in the superposition, because some of the students are there, they don't know even the network analysis. That's why I am using this simple example. So can we use superposition theorem? By superposition theorem, what superposition theorem says? What says that you will discuss in the network analysis. Okay, I want to tell you the answer. See, in the network analysis, whenever you want to switch off, what I am saying, repeating, मैं बोल रहा हूं, I am saying that suppose you want to switch off a voltage source. The rule is make it short circuit. Suppose you want to switch off the current source. Switch off the current source means current equal to 0. Make current equal to 0. Then what you have to do is make open circuit. Switch off means kill the voltage source, kill the current source. How to kill the voltage source? By short circuit. How to kill the current source or off the current source? By open circuit. Here both are voltage source, 3 volt, 5 volt. What superposition theorem says? One by one you will do the analysis. Suppose 3 volt is available and 5 volt is switched off. What is the voltage across R? Then second step is 5 volt is alone working, 5 volt is available, and 3 volt is switched off, then what is the voltage across R? And then you will find the overall voltage VR when both the sources are available. That is called superposition theorem, right? So now first step is A. Okay, A step is 3 volt is alone available. Okay, so make 3 volt battery. Okay, and this resistance is there. Okay, we have to calculate voltage across it, no doubt. Now this 5 volt is switched off. This 5 volt is switched off. Okay, switched off means voltage source is there, hence we have made it short circuit. Okay, now what is the voltage across R? This is the plus. Okay, this is the minus minus minus. Okay, so this is the voltage. Only one source is available, one element R is available. This 3 volt will come over here. Now see, this 3 volt polarity is matching with this VR polarity that is asked in the question. What is the value of VR? Okay, in the question what is asked? What is the value of VR? Okay, so VR polarity is plus here minus here. 3 volt polarity plus here minus here. So VR is equal to 3 volt. For this A case, so we can say the VR1 is equal to 3 volt. Okay, VR1. Okay, now B case. Case B. In case B, we will make this 3 volt switch off. We will on this 5 volt. So switch off the 3 volt source. 3 volt source is switched off. R is available, and this 5 volt is now available. Okay, this is your 5 volt. Now in this case, again only single battery is there. Because of this plus minus 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 minus. Okay, now this how much volt? Because only one battery is there, one resistor is there. This complete 5 volt will be across this resistor R. So this is your 5 volt. Now see, this 5 volt polarity, that is right side plus, left side minus, and match it with the VR given in the question. VR polarity plus is here, minus is here. Reverse polarity means minus voltage. Okay, so we can say VR2, this is your VR2, which is 5 volt. No, this is minus 5 volt, because so we are finding response because of this 3 volt and response because of this 5 volt across this resistor R. Okay, so overall voltage is VR, whose polarity is left side positive, right side negative. So overall voltage, therefore overall voltage VR is how much VR? VR1 is having same polarity, VR1 is having same polarity, and VR2 is having different polarity. So we can say VR is some VR1 plus VR2. VR1 is 3 volt, VR2 is 5 volt with minus sign. Okay, so VR2 is minus 5, answer is minus 2 volt. So many of you have given the answer minus 2 because of what? KVL equation. Okay, but here I have used what? Superposition theorem. But student is asking how minus sign? Minus sign is because the resistor is there and we are having multimeter pins. One pin of the multimeter. Okay, two pins of the multimeter. Multimeters have two pins, beta. One pin is positive pin, one pin is negative pin. Okay, so here positive pin, here negative pin. How 5 volt is coming over here? Now use different color. Minus 5 volt is coming like right side plus, left side minus. So now what is the reading of multimeter? Suppose you are having battery. Okay, I am having this battery. Okay, this is your battery. Okay, it is having this plus sign, this is minus sign. What is the meaning of this? This side potential is high, this side potential is low. If suppose I will use multimeter positive pin I am connecting over here, negative pin I am connecting over here, multimeter will give you positive quantity in the reading. Suppose plus 5 volt, plus 1.2 volt, 1.2 volt battery is okay, so 1.2 volt. If suppose I reverse the multimeter pins, like positive pin over here, negative pin over here, then multimeter will read minus 1.2 volt. Okay, so same way here we are measuring the voltage. Question is asking the voltage, this side positive, this side negative. What is the value of VR? Okay, Now during the calculation, this 5 volt is giving this side positive, this side negative, that is 5 volt. Meaning is that reverse voltage is coming across resistor R, meaning is that VR2 is -5 not +5. ठीक है? Okay. But student is asking, Pawan Sai Bignesh, superposition theorem is applicable for linear elements, but diode is non-linear. But I am not studying diode right now. We are not having any diode in the circuit. Okay, so let me complete first. Okay. If I am discussing diode and I am saying we are applying the superposition, you have to stop me. Sir, why we are applying the superposition? Then your question will be perfect. Right now your question timing is wrong. Okay. Okay. So right now we are having this. Okay. So what I am telling is, I am telling some concept of network that will be useful, that will be used in this subject so that other student will be comfortable, those who have not completed the network analysis. Okay. Okay. So check. Okay, so next discussion is before going to the diode. Okay, next. So superposition is clear, voltage division is clear. Now my question is this, because I am interested in this question, because this will be used again and again in my subject, and that's why I am discussing all these things. Okay, suppose you are having two batteries. Okay, one is V1 volt over here. Okay, and another is V2 volt over here, and we are having two resistors R1 and R2. Now my question is, what is this node voltage Vp? And this is, you know very well, this is your ground. So what is this node voltage Vp? How much this node voltage Vp is? Vp or Vx, whatever you want to call it, doesn't matter. Okay. So node voltage, first of all, what is the meaning of node voltage? Voltage at that node with respect to ground. Voltage at that node with respect to ground, that we have to calculate, right? Okay. So now what is the answer for this? Answer for this is, we can use the superposition theorem. Okay. We are having two voltage source V1 and V2. Because of that we want to calculate Vp. Those who are familiar with the network analysis, they can do by their own method, doesn't matter. I am telling the shortcut directly. What is this node voltage Vp? No doubt we are using superposition. Okay, so what is this node voltage Vp is? I am directly writing Vp. Now I am using superposition. What superposition says? V1 is acting alone and V2 is switched off. Okay, when V2 is switched off, it is short circuited. What is ground? Ground. This R2, this end will be ground, this end will be Vp. What is the meaning of Vp then? Vp is the voltage with respect to ground. Okay, so Vp means here plus and here minus, because this is ground. So voltage across R2 will be the Vp when V2 is switched off. Okay, I will erase it, no doubt. Okay, so Vp is the voltage across R2. What is the voltage across R2? V2 is off, V1 is acting alone. Series element R1 R2 are in the series and V1 is the voltage. Vp will be V1 into R2. Then I will tell you the shortcut, V1 into R2 upon R1 plus R2, total resistance. R1 plus R2. So this is the voltage because of V1. Okay, when V1 is acting alone. Suppose now, because we are using superposition, because two sources are there, this voltage because of V1. Now V1 is switched off and now V2 is acting alone. Then what is the Vp? Vp is the voltage with respect to ground. If this V1 is switched off, this is ground, then Vp will be this plus, this minus. Vp will be voltage across R1. What is voltage across R1? This is switched off because of V2. What is voltage across R1? Voltage division rule, V2 into R1 upon R1 plus R2. Okay, so let me erase it just for explanation. So Vp is voltage across R1, that is V2 is the total voltage multiply by R1, because voltage across R1 is this R1 plus R2. Meaning is that directly what you can remember to write the voltage equation. Suppose this is not like that, we can redraw it like that. Suppose it is like that. This is R1. Okay, this is R2, this is your V1, and this is your V2. Two voltages are there, because we can write like that, because this voltage is nothing but with respect to ground, V1 is with respect to ground, and you want to calculate this node voltage Vp. Now listen carefully what I am saying, just how to remember it. The concept is, suppose we are having two resistors R1 and R2, and I am asking for center voltage. This is R2, this is R1, center node voltage, and both the sides you are having two voltage source V1 and V2. Then what is the equation? Quickly we have to write, Vp will be equal to V1 into opposite resistance, V1 into R2 upon R1 plus R2, plus V2 into R1 upon R1 plus R2. Directly you can write like that. Okay, so Vp will be equal to how much? Vp will be equal to V1 into R2 upon R1 plus R2 plus V2 into R1 upon R1 plus R2. So this is your superposition plus voltage division rule. So what we are applying over here? Superposition plus voltage division rule. Okay, so this is the answer. So for V2 voltage across R1 is negative? No, it is positive only. Okay, redraw the circuit two times. Okay, otherwise remember this. Okay, so those who have not complete network, do not involve yourself too much in the network analysis. Okay, otherwise your analog circuit will be gone. Okay, if you want to study analog circuit, just what I am telling you, just accept it. Okay, I am not teaching network analysis. If I am teaching network analysis, then I will be giving too much time, like how much hours are there for network analysis only, and in that case I will be drawing this circuit again and again. Here my objective is to give you quick idea about particular calculation which depends on the network analysis. Okay, so now let's move to the discussion of the diode circuit. Okay, so now first topic in the diode circuit is diode with respect to DC. Okay, diode with respect to DC means, now see what is happening now. When you are having the mic problem or everything, too much messages are there. When study is starting, very less messages are there, less comments are there. Okay, because people are interested in some nonsense. Sir, some echo is coming, sir, some noise is coming. Okay, voice is low, even though voice is full, but in the laptop it is coming less, or in the mobile or in your device is coming less, so voice is less. But when we have started studying now, and then now see the messages. Otherwise last time, messages are like that, calling is like that. That is the reality. Okay. Okay, chal, let's. So this is just for fun. Okay. So diode with respect to DC source. Okay. So diode with DC. Okay. Sir, please explain voltage division rule. Voltage division. I have explained already, na. Voltage division. That is the problem here. Okay. Because I am unable to teach analog circuit because of network. And how I will manage it? Okay. Now sound is clear. Okay. One is asking sir voltage division. Forget about that. Just continue from here. Okay. So now diode. Okay. So diode is a device that you might have studied in electronic devices, and probably you will study in the electronic devices. It is a two-terminal device. One side is p-type semiconductor and one side it is a n-type semiconductor, and it can act as a switch. Why it can act as a switch? Because it is having a beautiful property, beautiful characteristics. If we draw characteristics between current and voltage, it is like that. In the forward bias, current is exponentially increasing, and in the reverse bias, current is very negligible. That's why this device can act as a switch. Feeling is that this device says I can allow current in this direction, because symbol itself saying, the symbol meaning itself is it can allow current in this direction, in this arrow direction, but it does not allow current in this N to P direction. Very negligible current can flow in the N to P direction. That is the meaning of this symbol of the diode. Okay, so here in the diode, this is your P side. P means positive, no. p-type semiconductor, and this is your n side, and this is your p-n junction diode, whose characteristics between current I and voltage given over here. How? Let me draw once again the diode symbol. So this is your diode. Okay. This is your diode. In P2N direction, some current that is flowing is known as diode current, that is ID, and this is your voltage VD, diode voltage VD. P side positive, N side negative. What is the meaning of that? So why you are connecting P side positive, N side negative? No, I am not connecting like that. It is the multimeter pins. When I am connecting multimeter, I am connecting positive pin of multimeter over here, negative pin over here, and I am measuring the voltage, how much voltage there. Okay, that is known as VD. And this ID and VD is having beautiful equation, relation we can say, that is ID is equal to diode current, ID is equal to IS, ID equal to IS, e to the power of diode voltage VD, exponential device. Okay, ID equal to IS, where IS is some constant, forget about what is IS right now, upon eta times of thermal voltage VT minus 1. This is the basic equation of the diode current. Okay. Now the point is, what is IS, what is eta, what is VT, everything. VD is diode voltage, ID is diode current. Diode current direction is P2N. Okay. ID is P2N direction current. Okay, sir. What is IS? IS is reverse saturation current. What is eta? First of all, eta is ideality factor. Ideality factor. Ideality factor. And this eta will be equal to 1 for germanium, because germanium is one of the semiconductor and silicon is another semiconductor material from which this device diode is made. Okay, and this eta is equal to 2 for silicon. This is the standard value of eta, some ideality factor. What is IS? IS is your reverse saturation current. Reverse saturation current. Sir, what is reverse saturation current? What is the meaning of it? Doesn't matter. What I am telling, just focus on that, because your subject is analog circuit, and this in this 120 hours or 125 hours we are going to discuss analog circuit nicely, and another 100 or 100 or 10 hours are for electronic devices, where we will discuss what is IS only. Okay, so this IS is reverse saturation current. Reverse saturation current, some constant factor you can remember right now. Okay, so IS is your reverse saturation current. So ID, diode current in P2N direction, because this is your P side of the diode and this is your N side of the diode. In the arrow direction, this is P, this is N. So from P2N direction, this current ID is equal to some constant IS multiplied by e to the power of diode voltage. Voltage is measured like P side positive, N side negative, that is VD upon eta VT minus 1. Okay. And eta is ideality factor and IS is reverse saturation current, and sometimes it is also known as leakage current. Okay. Okay. Now what is VT? VT is your thermal voltage. VT is your thermal voltage. And what is the value of VT? VT, great equation about this VT is given by Einstein, that VT is equal to temperature T upon 11,600. Remember this formula. VT is equal to temperature T upon 11,600. Now the question is, sir, what is this T? T is the temperature. Temperature means, sir, Kelvin or degree centigrade. This temperature T is in Kelvin. This temperature T is in the Kelvin. So whatever temperature we are having, convert that temperature in the Kelvin first, put that temperature over here, then divide by 11,600. Whatever number you will get, that is known as thermal voltage. Okay, that is the value of thermal voltage. Now after this, forget everything. Just forget everything. Now come to this, because we have to discuss the application of a diode, how it can be utilized in the circuit, how it can be used as a switch. Okay, so now this is the characteristic of the diode. Whenever some current is flowing in the diode and there is a voltage Vd, we observe this characteristics of a diode because this is the exponential relation. If we plot it, id equal to is e to the power of Vd upon eta Vt minus 1, id is depending exponentially on the Vd. So id will vary exponentially with the Vd. Okay, sir. So id will be increasing exponentially with the Vd. So Vd is the voltage. So this is your Vd, diode voltage, and this is your diode current id. So id is increasing exponentially with Vd. As Vd is increasing, id is increasing, or we can say as current is increasing, we are measuring this voltage Vd across the diode with the help of multimeter. This voltage is increasing slowly, but current is increasing exponentially. So this is the relationship. In this first quadrant, whatever characteristics is there, that characteristics is known as forward characteristics. Because in this case, current is very large. Because with this voltage range, if we look at this voltage range, current is having some milliampere range. Okay, if we give some numbers over here, some 1 milliampere, 2 milliampere, 3 milliampere, 4 milliampere. Meaning is that in the P2N direction, sufficient current flows whenever P side voltage is positive with respect to N side voltage, or we can say diode is forward bias. In this case, current is exponentially related and a nice current is flowing in the device. Okay, that's why we can say this diode is on or this switch is on, because whenever in your home some switch you are switching on, current is flowing in the devices and then your bulb is glowing, your tube light is glowing. Meaning is that switch is on. Switch is on means some current is flowing, current allows to flow in the circuit, right? So meaning is that this is the on condition. So what about this? What about this is, let me explain for that. Okay, so now this is the equation of the diode current. Okay, so now let's discuss this current equation in more detail. id equal to is e to the power of diode voltage Vd upon eta Vt minus 1. This is the actual equation of diode current. Okay, now let's come to the forward bias and reverse bias. What is the meaning of forward bias? Suppose this is your diode and across this diode, this is your P side and this is your N side. Suppose you are applying some positive potential over here and with respect to this N terminal, some positive quantity voltage, suppose 0.2 volt, 0.3 volt, 0.4 volt, 0.5 volt, 0.6 volt, 0.7 volt or 1 volt. You are applying, like in how you are connecting? You are connecting like that. For example, I am telling the battery like that. You are connecting like that. So P side positive, N side negative. You are connecting some battery, some potential, some voltage across the diode. Because of that, what will happen? A current will flow in P to N direction. A current will flow. And this is the case where current is flowing significantly across the diode, and this diode is named as on diode or forward bias diode. Okay, so diode is forward bias. Now in this case, because of this battery, suppose some resistance is also there, no problem. Okay, you can draw some resistance also here. Okay, no problem, some resistance. Because of this battery, we are having some voltage across the diode. Diode P terminal is having some positive potential with respect to this N terminal. Because of that, significant current is flowing. Meaning is that if we talk about the diode voltage, here you will have some voltage across the diode. This is plus and this is minus. You will be having some voltage across the diode, that is Vd. And this Vd will be sufficient. Okay. Some student is asking, sir, what is thermal voltage? Beta, listen carefully. I told you. First of all, analog circuit is the subject that you should study after electronic devices and network analysis. If you are studying before network and electronic devices, you have to have patience, okay? Because this subject is depending on EDC and network analysis. But sir, you told that EDC is not required, because I told on the basis of that I was thinking that you will be having some patience. No doubt, each term, whatever term is coming over here, that will be completely discussed in the electronic devices. For example, suppose I ask you one equation like E is equal to mc square. Have you ever proved this equation? Anyone? Just reply me. Okay, just reply me. E is equal to mc square. Anyone who has proved this equation? E is equal to mc square. I am giving the answer, best answer to you. E is equal to mc square. And you might have used this equation in many times in multiple subjects. Okay, no, but how you believe that E is equal to mc square is correct, and still you are having a great feeling and you are having to discuss all the phenomena based on E equal to mc square. Now the answer is, okay, that you are applying over here. In this subject you are dealing with application of the device. Please do not involve yourself in a great level, sir, what is thermal voltage. Otherwise I will have to move to Einstein relationship, that is dN by mu n equal to dP by mu p equal to bt equal to kt is equal to kt by q equal to t upon 11,600, and this is the equation given by the Einstein, where one is diffusion constant of electron divided by mobility of electron, that is equal to diffusivity of holes divided by mobility of holes is equal to K is Boltzmann constant. Okay, so meaning is that just you have to understand what I am writing on the board. Writing on the board means some application, some concept you have to understand. What is BT? Just forget T upon 11,600. Okay, I am happy like that. Just feel like that. Okay, yeah, I am happy. What is IS? So I have not told in the class. No problem, because something is missing, that is IS you will study in the electronic devices. Okay, now suppose in the electronic devices, suppose I am discussing this device will be used in the Kilper circuit. Now what student is asking, sir, what is Kilper circuit? Then in the EDC I am saying that Kilper circuit you will be studying in the analog circuit, right? Meaning is that interdependency is there. Suppose you are using some mathematical equation like differential equation in any subject, just think differential equation will be discussed in the mathematics. Okay, so you have to clarify that in a particular subject you will be having particular discussion. Try to understand that all the things, and once you will be going in particular subject like network, like electronic devices, then you will see, yes sir told this, okay, now yes, then you will be having this feeling. Okay, that will be completely different. So here you have to feel the circuit point of view. Okay, right. Okay, so let's discuss. Okay, so this is some positive, this is negative. So diode is having some positive potential on p side, negative potential on n side, and it is no doubt forward bias. Okay, so this is case forward. Now what is the voltage across diode? This BD will be positive or negative. Now in this case we will say this BD is positive, because in this case, in this equation, what is the meaning of BD? BD means p side positive, n side negative. If BD voltage, p side voltage is positive, n side voltage is negative, then BD is considered as positive, right? And ID is also considered as positive, or ID is considered flowing from p to n. So think this equation meaning is ID direction is p to n. ID is positive when VD is positive. Okay, or when VD is like p side positive potential, n side negative potential because of some battery. Okay, so now in this case this VD is positive. Now in this case this VD is positive, so I can write this VD is greater than 0, that is positive, or we can say VD is positive. BD is positive. Okay, so BD is greater than 0 or BD is positive. Now BD is greater than 0, BD is positive. So in this case, now think about this, e to the power of BD upon eta BT. Okay, now this is the equation. We are having calculator also, you also are having calculator. BD is positive quantity, BD is greater than 0 or BD is positive, so exponential positive number. BT is thermal voltage whose value is T upon 11,600. If suppose we calculate this BT at 300 Kelvin, what is the value of BT? VT value is, if we put 300 Kelvin, 300 upon 11,600, then it will come approximately 0.026 volt. Okay, now think. So this is the standard value of BT at 300 Kelvin. 300 Kelvin is also known as room temperature. Okay. Now see, e to the power of BD upon eta BT. One student is saying, sir, there is no EDC for double E. Then what I can do is, okay, you are not having patience. Okay, I always used to say, Please, God, give some patience to the students in the online class. Okay, something is not, you are having always complaint, meaning is that you are never ready to understand the subject, never ready to, what I say is, I'm completely disappointed. First time in the 10 years of my life, first time I am feeling disappointed. First time. This is my first batch of my life where in the very first beginning class I am feeling disappointed. First time in the 10 years. Or just go and search on the Google who is Kamesh sir first of all. On the social medias. Ask your senior who are 3 year, 4 year older than you. Then you will come to know who is teaching you first of all. So that you will have some confidence. That's just not to brag myself, okay? Have some confidence. Believe me, now first you are here to understand the analog circuit, not for the research of like what is EDC. Otherwise, this complete subject EDC, analog circuit and network, then I can teach 1,000 hours. Do you have this much of budget of the time for the examination? No. You have to score marks. You have to clear the subject perfectly. Everything is in the engineering is beyond the boundaries. Otherwise, I can explain this reverse saturation current IS for 20 hours. Reverse saturation current itself we can discuss. But you are not interested in attending the class. You are focusing on some nonsense only. Sir, what is BT? Unnecessary. Just I told in the introduction, this subject depends on these two subjects. Okay. It's not my mistake that I am teaching this subject to you. Okay. I have taken this much of PPT because earlier in this 1.5 hours, how much I have discussed in the previous analog circuit class last time, this much I have discussed. Okay. According to that, I have made this PPT, but we are stuck on the network analysis itself in 2 hours. And then people says that how much time is involved here. Okay, so e to the power of Vd upon eta Vt. Okay, so Vt is how much that I told you. How much Vt? So if you are feeling difficulty in anything, then you have to wait. You can use Khazana. You can use some recorded version of some courses available for network analysis. Okay, please do not spoil the class. Okay, so e to the power of Vd upon eta Vt. Okay, now okay, so Vt is 0.026, very small number. This Vt is 0.026. Eta is some number 1 or 2. So meaning is that just think like it is 0.026. And Vd is some positive. We are having calculator. Okay, we are having calculator. On the calculator, just write e to the power of some positive number, some number like 0.5 Vd, 0.6, 0.7 or 0.8 or 1 volt divided by 0.026. You will find that this number will be very large compared to this one. This number will be very large. This number will come very large compared to 1 if this Vd is positive. If it is so, in that case, we can neglect this one. So definitely this ID will be Is e to the power of Vd upon eta Vt minus 1. And this 1 is neglected. That's why I can say this ID will be equal to approximately Is e to the power of Vd upon eta Vt. So we can write like this. So this is your equation of the diode current in the forward bias. And this ID is flowing in what direction? P to N direction. Because currents always have some direction, and the direction of this ID is P to N direction. So P to N direction current is this much. Some constant Is multiplied by e to the power of Vd upon eta Vt. This much of current is flowing from P to N direction. Okay. So this is the current ID. Now in this case, what is happening when Vd is positive? This is known as forward bias. We can say this is forward bias. And this forward bias is also known as, we can say, diode is on. Okay. Counterpart of this is, reverse of this is, second case, suppose this is the equation of diode current, no doubt. Suppose diode is there, okay. Suppose diode is there, okay. This is the P side of the diode, and this is the N side of the diode, okay. Suppose some resistor is there, no doubt, some resistor. Now battery is like that. this side negative, this side positive. This side positive, one side negative, like that. Meaning is that the battery source which is available, okay, which is connected like that, N side positive, P side negative. Now listen carefully. What is happening? Circuit is like that. Arrangement of circuit is like that. The battery, yeah, current source is like that. That battery, how battery flows the current? From plus to minus. So this battery is supplying current from N to P direction, like that. Here, this battery is supplying current. Current always flows from positive to negative. So this current is like that. Current direction is P to N. Diode is on. Diode is forward bias. P to N. P to N current. Positive current means P to N current. Negative current means N to P current. Okay. So meaning is that this is the case. So N side positive, P side negative. Currents want to flow like that. But diode says, I will not allow current in N to P direction. Now question is why? Why it is like that? In this case, the current is nicely explained by ID equal to Is e to the power of Vd upon eta Vt. This is a very large number. Is is some number multiplied by large number. This current is milliampere range. If we calculate, it is a milliampere range. But now in this case, again we will write the equation of ID. But before that, now what is the voltage? Here plus, here minus. So voltage will be like that. Now Vd is positive or negative? I told you already. Positive Vd means P side positive, N side negative. If this type of voltage is provided by the battery, then we will say Vd is positive. But I am repeating once again. If a battery is providing voltage to the diode in such a way that the P side is connected with the positive of the battery and N side is connected with the negative of the battery, then Vd is positive. We will say diode voltage is positive. Okay. Now in this case, battery is connected such that battery is providing positive potential over here, negative potential over here. It means Vd is negative. Okay, so now Vd is negative. So now in this case, I will say this Vd is less than 0, or write like that, Vd is negative. Vd is negative. Negative. Listen carefully. You will enjoy this subject. Definitely. You will feel like that this is your favorite subject. Still I will say, okay, you will enjoy and you will feel like that this is your favorite subject. Okay, so Vd is less than 0, Vd is negative. Okay, now ठीक. Okay, now in this case ID is equal to equation again, because this is the equation of diode current. It is applicable, no doubt. I am writing ID equal to Is, where this ID is P to N direction. And network analysis says if current is flowing like that or like that, both are same, just a negative sign only. Suppose this current is plus 10 ampere, then this current is minus 10 ampere in any case. So we can still write this equation ID equal to Is e to the power of Vd upon eta Vt minus 1. This is the actual equation of current. Now you will come to know what is the current in this case. Okay. Now in this case Vd is negative. Now listen carefully. E to the power of Vd upon eta Vt. Like that. In this case, what I have written is Vd is positive. So positive upon some number which is very small. Number divided by small is very large number. E to the power of positive and large number was there. Positive and large, exponential positive and large, put in the calculator, you will see it is much greater than 1 in this case. But in this case, Vd is negative. Okay, so Vd is negative. Suppose minus 0.5, minus 0.6. Because of this battery, some negative voltage is coming across the diode. N side positive, P side negative. This type of voltage is known as negative voltage. And this is coming across the diode, and this voltage is suppose 1 volt. 1 volt, which is negative, minus 1 volt divided by eta times of Vt. If we calculate it, Vt is 0.026, get 26 millivolt. If we put, this will come very less than compared to 1. Now see, here it is written A minus B, where this 1 is very much high. This 1 is high compared to this. We will neglect which term? This term or this term? We will neglect this exponential term, which is very small compared to 1. So now this ID. In this equation, what is the meaning of ID? In this equation, ID means current in P to N direction. Okay, sir. P to N direction. This equation is saying that current is in P2N direction is equal to Is e to the power of diode voltage upon eta Vt minus 1. Because of this case, this exponential term will be neglected. Vd upon eta Vt minus 1. Okay. Now this e to the power of Vd. Now if you are having any difficulty in this explanation, that is your question. That you have to ask. Okay. That I will give you the explanation, no problem. So this e to the power Vd upon eta Vt we will neglect. This will be neglected. If this is neglected, what is the current? Id. Id will be Is multiplied by minus 1. What is the current? Minus Is. What is the Id meaning? Id meaning current flowing in P2N direction. Yes. So this Id is P2N. Yes or no? Id direction of current is P2N. In the P2N direction, minus Is current is flowing. What is the alternate meaning of this? In left to right, suppose current is plus 10, then right to left, what is the current? Minus 10. Meaning is that this current is suppose, for example, plus 1 ampere, then this current is minus 1 ampere. Okay. Yes. So meaning is that, just for understanding, I am writing over here. Okay. So this Id P2N direction is minus Is. Then what is the meaning of Id in N to P direction? P2N minus Is. So N to P direction current is, so Id in N to P direction. N to P direction. How much? Id in N to P direction plus Is. Okay. So when diode voltage is like that, diode is connected like that, the current is flowing in N to P direction, which is Is, and this Is is very negligible. This is microampere or nanoampere range, and this is approximately equal to 0, and this Is is very small value current, and this is approximate, not exactly 0. I am not saying Is is 0. I am saying Is is very negligible. What is the meaning of negligible? Negligible meaning means the money of Ambani and you are having the money. You are still having some money in your pocket. Okay, right now. Don't say like that, sir, I am not having any money, please give me. Okay, that is not discussed over here. Okay, I am not distributing any money. But suppose you are having some money. Okay, so your father is having some money, for example. That money compared to Ambani money is negligible. But still you are having money. Like that, this Is is negligible compared to what? Forward bias current, because this case is reverse bias case, because in this case direction of current is P2N and we are calling it forward bias. In this case current direction is N to P. Obviously we have to give some name opposite to this. This is forward bias, hence this is known as reverse bias. So in the reverse bias, how much current is flowing? Is current is flowing. Direction of current is from N to P. Why you are not writing in the comments? Why you are not participating in the current? You have to participate. Okay. In my class, you have to participate. You have to enjoy. You have all the rights to ask the doubt. You have to ask the doubt. No problem. But whenever I am stopping, please, this doubt is not relevant. Just stop over there, because that may be depending on some other subject. Okay, because the scope of this subject that I am dealing over here in a beautiful manner. Okay, so meaning is that this is reverse bias case. Now the question is, this Is is not exactly 0. I am saying this is approximately 0, just like your money and your father, or your Ambani money or your money. Okay. Now come back to the characteristics. Now this is Id versus Vd. Now on the characteristics, if I plot x by plot, this is x, this is y. In this x y plot, this Vd is the voltage across the diode, here plus, here minus, and this current is from P2N direction. This voltage is 0 point. Okay. If Vd is positive means plus x. Okay, plus. If Vd is positive, what is the meaning of that? If this Vd is positive, this side is plus, this side is minus, positive voltage. Diode is forward bias. What is the relation between Id and Vd? What is the relation between Id and Vd? Id is exponentially depending on Vd. That's why this plot is exponential. So current ID is increasing exponentially with VD. When VD is very small, current is negligible only, and when VD is sufficient, current is increasing. Okay. Now, what about the reverse bias case? When VD is negative, less than 0, VD is less than 0, VD is less than 0 or reverse bias, VD is negative, or we can say the current is in N to P direction. Okay. So in P to N direction, current is positive. In by X plane, yeah, X by plot, upside is positive by, right? This is by, this is X. Here by is positive, here by is positive, here by is positive. Where by is negative over here. So your by axis is current. Current is in N to P direction, that you are saying that it is negative. Why negative? Because in P to N you are saying current is positive, in N to P you are saying current is negative. That's why you are drawing current over here on the third quadrant. So first quadrant is for the forward bias when VD is positive. Second quadrant is for VD negative. Third quadrant is also for VD negative. But when VD is negative, current is in N to P direction or negative current. That's why you are plotting over here. Okay, sir. Plotting over here. Okay, right. Now, during plotting, this current is very small because this is very near to this horizontal axis. And this current value is IS. And that IS is negligible, very small. Or we can write over here. I can also write, okay. Here no problem. This IS current is in the nanoampere range or microampere range. Okay, this is in the nanoampere range for silicon diode, and this is in the microampere range for germanium diode. अब nanoampere and microampere comparatively very small compared to milliampere, which is flowing in the forward bias. Forward bias comparison, it is very negligible. That's why we can say this is approximately 0. Okay, approximately 0. So that's why it is very small. So this is your IS current. So here I can write this amount of current is nothing but IS, and this IS is in microampere, or this IS is in the nanoampere, microampere for germanium and for silicon. Otherwise, this IS is finally we can say approximately 0. This is the characteristics. Now listen carefully. What is the observation from this characteristics? Okay. Sir, in the slide 9 under ID it is N to P direction, right? Slide 9. 9 slide is there under ID. Where beta? Okay. Sir, in slide 9 under ID it is N to P direction. No, this is the generalized case P to N, and then after 9 this is 10. This is forward bias case where P side positive, N side negative, current is in the P to N direction. Here in this case N side positive, P side negative. Okay, so current is in N to P direction. Okay, so in the N to P direction current, so this is your general equation where direction of current is from P to N. This is general equation. General equation of diode never differentiate between reverse bias or forward bias. Shockley has given diode equation which is including this exponential and -1. When both are included, always think this is the equation of current for both the bias, reverse bias as well as for forward bias. And in this case, the direction of current is from P to N only. After performing some approximation, that is e to the power of BD upon eta, BT is very small compared to 1 because of reverse bias, because of negative value of BD. That's why this ID is coming -10, for example, -10 nanoampere. ID in P to N direction is -10 nanoampere, or we can say ID is +10 nanoampere from N to P. Or really, because of this battery, current can flow from here to here in the N to P direction. But this current is very small, negligible. We can say current is 0. That's why in the reverse bias we can make diode open circuit. Okay, now diode will be open circuit in the reverse bias, because in the reverse bias how much current is there? Negligible current is there. Which element in the network analysis have 0 current, negligible current? That is open circuit. So that's why, what is the rule now? What you have understood from this characteristics of a diode? Diode says, diode is speaking that in the reverse bias, when voltage across me is negative, what is the meaning of negative? First of all, understand. Do not by heart. Negative means if suppose I am connected in any circuit like that, my N terminal is connected with positive terminal of the battery or high potential side, and my P terminal is connected with low potential side, then I will say I am reverse bias. My current is in N to P direction, and in the N to P direction, ideally I do not allow current. I will say like that, and my current is 0, and I will become open circuited. Okay, so in the reverse bias, diode will be open circuit. That is clear. Okay. Now the problem is with the forward bias. In the reverse bias, we can make diode open circuit. We are having some switch behavior. What is the meaning of switch? What is the meaning of switch? Suppose I am having some switch, but I am not having any board to show you. So switch, what we do with the switch? Suppose switch is on, light is on. Switch is off, light is off. Switch on, switch off. Switch on, switch off. Meaning is that switch is something that allows current in one direction and block current in other direction. Okay, right? Okay, so meaning is that this diode is telling same thing. In this case I am having approximately 0 current, I am not allowing current, but in this case I am having milliampere range current, some current which is changing with the voltage, and significant current is there. Meaning is that in the forward bias we can say diode is on switch, and in the reverse bias we can say diode is a off switch. Okay, so we can say finally, so after this we can say in a forward bias diode is a on switch. Okay, if today's class will take some time, don't worry, because 20 minutes already we have started late class because of some problem. Okay, now tell me, actually some of you are saying that now my voice is proper. How automatically it is coming? That is the part of the exploration. Okay. Okay, so now, okay, so let me know. Okay, so whenever this type of thing is going on, you can message me on the Telegram, tell me about it. Okay, anything. Okay, no problem. Just think like that you are studying from a teacher who is readily always available for you. Okay, don't worry, but just study the class, enjoy the class, take questions, solve the question, send the message, no problem. Okay. Okay. Okay, current source we will discuss, no doubt. Instead of voltage source we will have current source. Everything we will discuss, just it is the introduction. Okay. Okay, so now in this case what we can say, in a forward bias, forward bias means meaning P side positive potential and side negative potential. It is on switch. Okay, in reverse bias it is off switch. Okay, this is the conclusion. Now the main problem is, suppose for example, let me show you one question. Okay, suppose you want to solve this question. Here in this question, this is not a diode circuit question. Just think like a network. With the analog you will be having 3 network classes. Okay, in this circuit, complete circuit is looking like a network. You have to find out voltage across it, but the point is diode is there. But you know very well diode is a non-linear element because the characteristics is non-linear. So characteristics is non-linear, so diode is non-linear. Now the problem is, in your network analysis you generally prefer to do linear circuit analysis. Why? Because in the linear circuit you are having simple equation, simplicity is there, very easy to solve with the help of hand only, with your calculations only. You need not require any MATLAB or any softwares for the linear circuit analysis because its analysis is easy. That's why in the network analysis, whenever you are having linear circuit, you feel more comfortable compared to non-linear circuit. And if suppose you have gone through some books, title, not inside the book, only title, you might have seen it is written linear integrated circuit. you might be having some book on with the title linear circuits, linear integrated circuit. Why it is often written on the books? Because linear circuit analysis is very simple. Okay, linear circuit analysis is very simple, and the end of the class I will tell the name of the channel, everything. Okay, don't worry. Okay, so now the point is it is non-linear characteristics. Now we will do some approximation, and these approximations are done by the circuit engineers, or we can say scientists. How we can convert this non-linear behavior in this first quadrant of the diode into linear behavior. No doubt it is practically, or 100% we can say it is exponentially, but what are the possible assumptions we can take, or possible approximation we can have? So we will having three approximation. One is ideal diode approximation, second is cut-in voltage approximation, and third one is another approximation. So one by one, to convert that diode characteristics into some linear type of characteristics, we are doing some approximation. So that is known as diode models, because we want to design some circuits using diode, and we have to analyze those circuits by hand calculations only. That's why we need these approximations. Otherwise diode is an exponential device, 100%. Okay, so this is first model, ideal diode model. Ideal diode model means, suppose you are having some diode like that. This is your diode, and this diode is known as ideal diode if this characteristics is like that, I versus V characteristics between diode current and voltage. Suppose this is your diode current I, and suppose this is your diode voltage V. Okay, ID VD we can say. Okay, no problem. This is ID and this is VD. Okay, now how to denote ID VD on the diode? I told you already. ID generalized way from P to N, and this voltage from P side positive, N side negative, just for notation. This is VD. This ID VD is related by exponential characteristics practically. But now the question is, suppose your diode is ideal diode model. In the ideal diode model, this is ID, this is VD, and this blue color characteristics is the actual, this is your approximated characteristics. That is known as ideal characteristics. No doubt, in the reverse wise, when VD is less than 0, I already told you that the current is 0. That is the reverse saturation current, and that current is very much good approximated with 0 only. Okay, so that's why when VD is less than 0, current is 0, 0, 0, 0, 0, because current is coinciding with the 0 line. Because this vertical axis for current, in the vertical axis, if we are above from the origin, current is positive. If we are below from the origin, current is negative. And we are just at the origin line, current is 0 only. Okay, so current is 0 when VD is less than 0. But when VD is just 0 plus, we are seeing sharp transition. Sharp transition means when VD is just 0 plus, current can take any value, 1 milliampere, 2 milliampere, 3 milliampere, 4 milliampere, 5 milliampere, 6 milliampere. See, try to understand it. What is the characteristics? Characteristics is ID versus VD. When VD is less than 0, current is 0, just on 0. When VD is just 0 plus, current is sharp. What is the meaning of sharp current? Current can take any value, like that. You can say current can take any value, and that is positive only, because on the positive y-axis we are having current plotted. Okay, I will erase it, no doubt. Okay, so current can take any value, meaning is that current can have 1 milliampere, 2 milliampere, 3 milliampere, 4 milliampere, 5 milliampere, 6 milliampere, 7 milliampere, 100 milliampere, 200 milliampere, 300, any value. Now the question is, what is the meaning of this? What is the meaning of this? Because I told you already, we do not know about diode. I'm telling you, in the analog circuit, you just have to say that I don't know diode. You just have to say like, I don't know BJT, I don't know MOSFET. You have to say, I know network analysis, voltage source, current source, resistors, capacitor, that we do know. Okay. If we are able to convert diode into equivalent network circuit, BJT into its equivalent network circuit, then we are champion of the network analysis, and we can solve the question very easily. In the same manner, every time what you have to do is you have to replace diode with its equivalent network. Now my question is, which element in the network analysis has zero current? Which network element has, and the network analysis, when you have zero current. I am saying like that. And the question is, along with that, current is zero, but BD can be -1, -2, -3, -4, -5, -6, -7. When meaning is that BD can take, voltage can take any value, but current is zero. What is the concept of network? Which element in the network is having zero current and can have any voltage? Open circuit. Across open circuit, current is 100% zero, but voltage can take any value. So this is the meaning of this characteristic. So one by one, first is when this voltage VD is less than zero, when this voltage VD is less than zero, ideal diode case. In the ideal diode case, if diode is ideal and if we are measuring the voltage and that voltage is less than zero, what is the meaning of voltage less than zero? Voltage is positive on N side and voltage negative on P side. That is the meaning of BD less than zero, right? BD positive means P side voltage positive, N side voltage negative. That I told you already. So BD less than zero means reverse bias condition, we can say. Okay. N side positive potential, P side negative potential. In this case, when VD is less than zero, diode is reverse bias. That's it. Reverse bias case. Meaning is that suppose diode is there in the circuit, diode is connected with the battery in a manner that battery is providing this side positive potential, this side negative potential. That is the meaning of BD less than zero. In this case, diode is reverse bias and this diode will be replaced by, this is diode P side and this is diode N side. It will be replaced by open circuit. This is open circuit. Okay, it will be replaced by this. And diode will be having some voltage, no doubt. Here some positive, here some negative. That's why it is reverse bias. And this voltage may take any value. 1 volt, 2 volt, 3 volt, 4 volt, 5 volt. N side positive, P side negative. That you will be have some positive voltage, no doubt. If you measure like P side positive, N side negative, then it will come negative only. Okay. So we are saying this BD less than zero in the sense that we are measuring like that. P side positive potential, N side negative, and we are measuring with the multimeter plus terminal of the multimeter, negative terminal of the multimeter, but actual voltage is like that. Because of that, BD is negative. Clear? So don't get confused that BD is less than zero. Here suppose BD is less than zero, then again I will take another minus sign. So this is not your BD, this is the voltage measured in the circuit, and this voltage will obviously come positive. That's why, because N side positive, P side negative potential means diode is reverse bias. So have feelings of the reverse bias. Reverse bias means N side potential is high compared to P side. Or we can say, if we are measuring like that, suppose I am applying multimeter pin like that, positive pin of the multimeter, negative pin of the multimeter, that I am telling that this is VD. And this VD in the multimeter, we will see this is negative. Okay, so multimeter readings. So this is the term that I using in the form of reading of multimeter, where multimeter pin I am connecting P side positive and N side negative terminal of the multimeter. Okay, so this is the case. So don't get confused, just have practice and then definitely no problem will be there. Okay, so current is zero in this case. Second case. Now, second case is, suppose diode is connected. That's why you have to listen carefully. That is more important than anything that is written on the board. Suppose voltage across the diode is greater than zero. Voltage greater than zero. 0 plus. What is the meaning of that? Then forward bias. What is the meaning of voltage greater than zero? That's why I am telling again and again what is the meaning of. So meaning of BD greater than zero. Meaning, don't believe in the writing, just feel in the meaning. So meaning is that suppose diode is connected with the battery in such a way that P side positive potential of the battery is connected, N side negative potential. Meaning is that current can flow in P2N direction. If current is in P2N direction, diode is on. Forward bias diode. And this voltage we can say positive voltage. Okay. Now, okay. So forward bias. Now this diode, which is connected with the battery in a manner that here we are having some positive potential, negative. Then, what is the replacement of this diode? According to this characteristics, what we are seeing, when voltage is 0 plus, current can take any value, 1 milliampere, 2 milliampere, 3, 4, 5, 6, 7. Any current can flow,
but voltage is how much? Just zero. Voltage is just zero. The voltage across diode is just 0 plus, but current can take any value. Which element in the network is like that, that can have zero voltage drop but can allow any amount of current from 1 milliampere to 10 milliampere, 20, 30, any current? Short circuit. Short circuit is the path in any network analysis. You can have any current. Suppose in the network analysis you are solving 10 problems, you can have different answer of current across that short circuit, but one thing is constant, that is you will say voltage is zero all the time. Meaning is that diode will be replaced by short circuit between this P and N with the help of this short circuit. Meaning is that voltage is approximately near to zero, but current can take any value and direction of current will be P to N. So some concept we are developing. So in a forward bias diode or on diode, direction of current is from P to N. In a reverse bias diode, direction of current is N to P. However, in the reverse bias current is zero, that's why diode is open circuit. In the forward bias diode is short circuit. A diode is ideal. So this is the case of ideal diode. Okay. So meaning is that, what is the meaning of this zero we are comparing? It is a cut-in voltage we can say, because we are comparing with the zero. What is the meaning of that? When voltage across the diode is greater than zero, diode is on. Less than zero, diode is off. So here it is open switch, it is closed switch. Meaning is that this is the off condition. We can use another color of the pen. Okay. So this is the off condition. So off switch ho gaya. Diode is off switch and this is on switch. Off and on. Clear? Okay. Now let's move to next discussion. This is the first model. But in this model, suppose you are very honest. You will be saying, sir, how we can do this approximation? To the scientist you are saying, how it is possible? Actual diode is having something like that. Something characteristics like that. In the reverse bias, I am okay because that current is very near to zero. Okay. Well, you have approximated this characteristic to this. So scientists are saying, oh, it is ideal diode, we are assuming like that. But you are saying that to scientists you are discussing why you cannot approximate like that, because this current is exponential. Exponential plot means something like that, very steep. Can you approximate like that? Then it will be better. Okay. So according to that, the second approximation comes into the picture. Okay. So second approximation is this. Between I and V. Okay, sir. Between I and V. Second approximation. So this is diode current ID and this is your diode voltage VD. Okay. Again, this diode current, suppose this is ID and this is your voltage measured by the multimeter, that is VD, ID VD. And this is the characteristics. In this characteristics, this is known as the voltage. Earlier that was zero. You can say this is already the same characteristic that we have discussed already. That was shifted over here. That was here only. And that is shifted to the right. Okay. So earlier it was passing through origin. Now this is passing through some finite voltage that is called V gamma. And this V gamma is known as cut-in voltage. Cut-in voltage. Okay. So what is the meaning of cut-in voltage? That you will understand right now. Okay. So this cut-in voltage was zero earlier. In previous case it was zero only. Okay. Now in this case, again this is the characteristics. Now try to understand it. Now try to get some meaning from it. Okay. Now see. This is V gamma. When this diode voltage VD, this is your zero, some positive but less than V gamma. So VD is positive but less than V gamma, current is zero. VD is positive but less than V gamma, current is zero. Okay. When VD is negative, then also current is zero. Meaning is that when VD is less than V gamma, current is zero. Okay, current is zero. So meaning is that when VD is less than V gamma, current is zero. So we can write first point. In the second model, this model is given in the question, then they will indicate V gamma value. They will give you V gamma value. Okay. Now, So Vd is less than V gamma. Okay. When Vd is less than V gamma, again what you are seeing, Vd is less than V gamma, current is 0. Okay, so we can say the diode current ID is 0. Okay, diode current is 0, but voltage can take any value. When Vd is less than V gamma, voltage may be 2 volt, 3, suppose 0.8 volt, 0.6, 0.5, 0, minus 1, minus 2, minus 3. Any voltage is possible. Okay. So meaning is that the concept is if diode voltage is less than V gamma, even though suppose for example V gamma is 1 volt and diode voltage is less than 1 volt, suppose 0.9, 0.8, 0.7, 0.6, 0 or negative minus 0.1, minus 0.2, minus 0.5, minus 3, then in all the case current is 0. Now the question is, which element from the network do you feel have any voltage but current is 0? Which element of the network guaranteed that current is 0 and voltage can take any value? Which one? Okay. Let me know. I'm waiting for your answer. Open circuit. Again, yes. Open circuit can have any value, but voltage can have any value, but current is 0, 100%. Okay, so when Vd is less than V gamma, Id is 0, diode will be replaced by open circuit. Diode will be replaced by open circuit. Again open circuit. So meaning is that if it is ideal diode or second model of the diode, these are the models of the diode. So in any case, diode will be open circuit when diode voltage is less than cut-in voltage. Earlier case cut-in voltage was 0, we can say. Now cut-in voltage is finite. Okay, so open circuit, this is P, this is N, but diode can have any voltage. So open circuit can have any voltage. So voltage can be anything, but 100% this voltage will be less than V gamma, or we can say this voltage will be N side positive, P side negative, that is reverse bias, less than 0 case. Or if this voltage is P side positive, N side negative, then this voltage amount is less than V gamma. That's why diode is not getting on. Diode will be on when Vd is greater than V gamma. Let's see. Okay, so this voltage across the diode, this Vd, we can say either it is negative or it is less than V gamma, current is 0, diode will be replaced by open circuit, and this is known as off diode, we can say, or this is the reverse bias case, we can say. Okay, so just off diode, we can say off switch. This is off switch. Okay, next, second case. Second case is from here, Vd is greater than V gamma or just V gamma plus. At that time, how much current? Current 1 milliampere, 2 milliampere, 3 milliampere, 4 milliampere, 5 milliampere. Current can take any value. You can extend that blue color also, no problem. Okay. So current can take any value, but voltage is fixed at V gamma. Now tell me which element from the network analysis is like that whose voltage is constant, but it can have any value of current from 1 milliampere, 2 milliampere, 3 milliampere, 4 milliampere, 100 milliampere, 200 milliampere. Which element? Short circuit is having 0 volt. No. Voltage is V gamma. For example, let us assume V gamma is 1 volt. So which element is having constant voltage? 1 volt, 2 volt, one fixed voltage, and can have any value of current? Just let me know. Voltage source. Ideal voltage source of the network analysis has constant voltage and it can deliver any current or can take any current. That is the concept of network. Ideal voltage source. Or network need, sir, we have not studied network analysis. Here you are in the college. This much you already know, that is voltage source, which is current source. Okay, so not short circuit. Why not short circuit? Because voltage is V gamma. V gamma is a number which is some finite number, not 0. So 0 was earlier case. Ideal diode case. So now in this case, when Vd is greater than V gamma, diode voltage Vd is greater than V gamma. In that case, what is the current? Current can take any value from 0 to infinity. Current is positive, या current is not 0, or we can say current is greater than 0. Don't by heart. Current greater than 0 means current is flowing in P2N direction and can have any value greater than 0. Okay, just take it easy, just write by your own, do not by heart. Okay, so Vd is greater than V gamma, because once we solve the question you will feel this is the diode questions, this is the clipper circuit. Just you should know only basics of the network, then analog circuit is nothing. I am guaranteed you will score 10 out of 10 in the analog circuit with 100% accuracy. I'm telling you. Okay, so Vd is greater than V gamma, Id is some finite value greater than 0. Now what is the replacement of the diode? We are learning what? Replacement of the diode. Okay, so this is your diode. Suppose this is the diode voltage, P side positive, N side negative, some voltage Vd is there. After measuring this voltage, we come to know this voltage is greater than V gamma or less than V gamma. If this is less than V gamma, it will be open circuited. If it is greater than V gamma, then this diode will be replaced by a battery. Now the question is, battery has two terminals, one is positive terminal, one is negative terminal. You draw positive terminal bigger one, negative terminal smaller one, like that, no? Or like that also. Yes. So now what is the direction of the battery? How to draw the battery? Either like this or either like this. Now diode is in the forward bias mode. Diode voltage is actually positive. Positive means P side positive, N side negative. Diode is acting or operating in this region. In this region, diode voltage is positive. What is the meaning of positive? I already told you. P side positive, N side negative. So we will replace P side positive, N side negative, and it is a battery. It is a battery. This is your P side. This is your N side. Okay. And what is the amount of this battery? This battery is constant V gamma. Now see clearly. In the earlier case also it is just like a battery, but whose battery voltage is 0. So this is short circuit is nothing but battery of 0 volt, we can say. Here the battery is V gamma amount, current can take any value, but voltage is constant, and this constant voltage is V gamma. So this is the replacement of the diode. P side positive, N side negative with V gamma. So now think in the mind and just revise it. If you are having diode first or second model or any model, if diode is reverse bias, make it open circuit. That's it. Open circuit. When you will do the open circuit, when diode voltage is such that N side is connected with positive terminal, P side is connected with the negative terminal, diode is reverse bias, diode is off, just make it open circuit. That's it. Okay. Second case is forward bias. P side positive potential with respect to N side. Now diode is ideal, then make it short circuit. Now diode is second case where diode cut-in voltage V gamma is given, just V gamma is given. Diode is either open circuit if it is reverse bias, or voltage across the diode is less than V gamma. Which voltage of the diode? If you are measuring P side positive, N side negative, and this voltage is coming less than V gamma, diode is open circuit. Second case, if measured voltage is greater than V gamma, diode is on, and you have to make a battery, P side positive, N side negative. This is the replacement of diode. So this is again on switch. Okay, on switch we can say. Why on switch? Here current is 0, here current is finite. Now tell me how much current can flow. What is the direction of current in the on diode? When diode is on, direction of current is from P to N. So in the P to N direction, some current ID will be flowing. That ID may be 0.1 milliampere, 0.2, 0.3, 0.4, 0.5, but diode voltage is constant, current can be any value. Okay, so this is the case. This is the second replacement. Now let's go back to the ideal case so that we will have some more discussion. Now in this case, what is the slope of the characteristics? Now see, what is the slope over here? Now, what is the slope? The slope of this characteristics, if I want to calculate slope, in the second case when Vd is greater than 0, diode voltage just 0 or 0 plus, in that case what is the slope? How to calculate slope? This is y-axis, this is x-axis. Slope is delta by upon delta x. Okay, delta by means delta id upon delta vd. This is the slope. Now tell me, my friends, what is the meaning of resistance? What is the basic definition of resistance in any subject? Voltage upon current. What is written over here? Current upon voltage. Okay, current upon voltage. If I reverse it, what you will get? Voltage upon current. Meaning is that if I reverse the slope, we will get definition of resistance. Since this is the forward characteristics of the diode, because this second case is forward bias case, so what is the name given for that resistance? Forward resistance RF. So what is the forward resistance? So forward resistance here I am writing is equal to 1 upon this slope. This is slope. Reciprocal of slope is delta Vd upon delta Id. Right? Now tell me, what is the slope of this line? Suppose one line you are having like that. Okay, this is the line. What is the slope of this line? Suppose line is like that. What is the slope of this line? Just tell me. First of all, what is the slope of this line? Because we do not want to calculate something just from the feelings. Suppose some line is like that. Okay, what is the slope? 0. Then what is the slope of this line? Slope of this line. Slope of this line. Write in the English. This line, vertical line. Slope. I am not asking for angle. Okay. Slope means tan theta. Tan 90 is how much? Infinity slope. This line slope is 0. This is some angle. This is some 45 degree. Slope is 1. And this is slope is infinity. Yes. So this vertical line slope is equal to how much? Infinity. And what is written over here? Reciprocal of slope delta Vd upon delta Id. Slope is 0. Slope of 0 means 1 upon slope 0 means resistance is 0. Okay, RF is 0 ohm. Meaning is that in forward bias case, diode is replaced by a resistance which is 0 ohm, short circuit. A battery voltage 0 voltage battery in series with a resistance whose resistance is 0 only. So 0 resistance is short circuit, 0 voltage source is also short circuit. That's why it is acting like a short circuit. I will come to the some doubt any student is asking. Let me read first so that we can explain that. Okay. The diode current is flowing from P to N. Then the electron equivalent polarity need to be minus plus, right? Then the equivalent polarity need to be no. Okay. If current is flowing from P to N, then polarity will be P side positive, N side negative. Okay. So he might be asking over here. So current. Oh, he is confused between. So this battery is supplying current. Okay. This is not that battery. This is not your battery. This is the internal battery of the diode. Okay. That is not external battery. You might be confusing because you might getting confused because you are thinking like that. Suppose some elements are like that. Suppose some battery is like that. Okay. You might be thinking that current should be like that. Bilkul. Right. Current should be like that. But this is the external battery. Here you are having some another battery. Okay. And this battery is stronger battery. That's why current is coming like that. So this is the battery equivalent or equivalent of the diode, we can say. This is not the battery. This is the internal circuitry of the diode, we can say. Okay. Now see. One student is asking, sir, please repeat the RF concept once again. Okay. Now, just think about it. Second case. In the second case, it will be clear. Now, see here. So when VD is less than V gamma, current is zero. You are replacing diode with the open circuit. No problem. Okay. But here in this case, this line is vertical. You are replacing diode with the battery because battery voltage is constant. That I have told you in a better way. Which element in the network is there whose voltage is fixed? Because this line is vertical, voltage is fixed. Current can take any value. So voltage fixed, current can take any value. That is the voltage source. Okay, that's why you have replaced. Now the question is, now again, what is the slope over here? What is slope? What is the meaning of slope? Slope means from ninth class delta by upon delta x. Slope means delta by upon delta x. What is delta by? Delta ID upon delta VD. Okay, slope. Okay. Sir, what is resistance? Suppose resistance, name I am giving RF. My interest, I am giving some name RF. You can give the name R. Okay. You can give the name R theta, R lambda. And if your name is starting from S, you can give the name RS. No problem. So RF I am giving because I am dealing with the forward bias diode. This portion where VD is positive, it is known as forward bias. So RF will be equal to how much? Resistance. What is the definition of resistance? In the 8th class, resistance is V upon I. This is written V upon I or I upon V? I upon V. Let me write RF equal to V upon I. Delta VD upon delta ID. Then these are the two equations. What is relation between these two? Sir, this is written by upon x. This is written x upon y. Left side RF, right, left side slope. What is the relation between RF and slope? RF will be 1 upon slope. Okay, sir. So RF will be 1 upon slope. Okay, sir. Now, what is the slope of this line? What is the slope of this line? Vertical line. 9th class. In the 9th class, we have studied that a horizontal line like that have zero slope, and the line which is vertical has infinite slope. Slope is equal to infinite. Now, resistance is 1 upon slope. What is the meaning of infinity? Infinity means 1 upon 0. So infinity means 1 upon 0. Okay. Then RF will be slope 1 upon 0. Then we will write 0 upon 1. Answer will be 0. And this is 0 ohm. Okay. So that's why I am using different color. Okay. So now resistance is 0 ohm. Okay. 0 ohm resistance. Okay. So now resistance is 0 ohm. That's why you can see in the second case when VD is greater than V gamma or ID is greater than 0, ID is flowing from P to N. In that case, diode will be replaced by battery in series with a resistance. In series with a resistance whose value is 0 ohm. So you can think like that. No doubt it is a battery. Just think like that. Along with the battery, we are having a resistance in series, and that resistance is equal to 0 ohm. Okay. If this resistance is suppose 1 ohm, then what you will do? In battery, in series with, you will connect a resistance. Okay. Along with the battery. That is the third case. So third case is this. This is the third model of the diode, where IV characteristics of the diode is like this. Okay. This is diode current ID. This is diode voltage VD. So there are three cases of the diode model. Okay. This is your P, this is your N, and this is diode current ID. Okay, and this is your diode voltage VD. Okay, this is diode voltage VD. This is ID VD. Okay. Sir, in VT equal to T upon 11,600, what is the 11,600 implies? 11,600 is just a number. Okay, it is just a number. Okay, he is still there in the VT memories. Okay. Okay, now in this case, suppose this is given, and here this is known as again V gamma. where V gamma means V gamma is cut in voltage. Cut in voltage. Okay, V gamma means cut in voltage. Okay, now this characteristics is very similar to the previous characteristics, only the difference is apart from this vertical line we are having line at some angle, some slope of the line is present, slope is finite, slope is not infinite. Okay, now in this case again we can make two cases. Now do it fast. When Vd is less than V gamma, how much current is there? Zero current is there. Again diode is open circuit. So don't say sir why you are speeding up, because we are having now better understanding. So Vd is less than V gamma. At that time what we are seeing, current is zero. Current is zero. Since current is zero, which element in the network is having zero current? So many elements can have, but along with zero current, voltage can take any value. Okay sir, any element which can have any value of voltage, but current is zero, that is the must condition. Current is zero in the open circuit, along with it can have any voltage. Okay, so diode will be replaced by open circuit. So again it is off switch. This is P side, this is N side. Okay, P side, N side. This is the case where voltage, this is the Vd that we have measured, and that voltage we are getting less than V gamma. Second case, Vd is greater than V gamma. Okay, if Vd is greater than V gamma, obviously what we are having, when Vd is greater than V gamma, we are not having zero current, we are having some current which is finite. When Vd is greater than V gamma, current is 1 milliampere, 2 milliampere, 3 milliampere, 4, 5, any value. Okay, so current can have any value, sir. Okay, fine. So current can take any value, so we can write current is any value but greater than zero, some positive number, because in this case current is on the upper side, meaning is that current is positive, P2N direction current. Okay, now what is the replacement of a diode? Now I am drawing diode like that so that you will be having better understanding. Doesn't matter, we can write like that. Suppose this is your diode, this is the P terminal of the diode, this is N terminal of the diode, and this is the voltage across the diode that you are measuring with the help of multimeter. If this voltage after measurement is less than V gamma, that will be open circuit. If this voltage, if this matlab P side positive, N side negative, this voltage coming greater than V gamma, so meaning is that diode P terminal is having higher voltage than N terminal, along with that it is having voltage greater than V gamma, cut in voltage, more than cut in voltage, then this diode will be replaced by, again, what is the meaning of this? Earlier you were having some vertical line, you were replacing the diode with a battery. Okay, just think like that, it is a vertical line only. If it is vertical line, we were replacing diode with the help of V gamma, P side positive, N side negative, and this was cut in voltage V gamma, and this was the P side. Okay, this is the P side, P2 and V gamma. But now slope, look at the slope, how much slope we are having. Let me change the color of pen. Okay, so this is your slope. What is the slope now? Again, slope is, I am not writing definition of slope right now. Okay, slope is finite or infinite? Slope is non-zero. Okay, so slope is not zero, is it non-zero? Slope is not equal to zero. If slope is not equal to zero, what we can say is RF, that was equal to 1 upon slope. If slope is infinity, if slope was infinity, RF was zero. RF was zero at that time. Now slope is finite. If slope is finite, 1 upon slope is finite. Okay, so this RF is some finite resistor. Meaning is that earlier we were having zero resistance. Now that resistance is having some finite value. This is your RF. So meaning is that this is your complete representation of diode between P and N terminal. So this is the internal structure of a diode. Diode can be replaced by a battery in series with a resistor. This is the representation of diode. Meaning is that suppose I can draw like that for a better understanding. So this was the diode voltage and this was the diode current ID, which is flowing in P2N direction, some finite current. Now in this case, diode complete voltage is this. This is your diode voltage VD and this is your diode current ID. And diode is replaced by this V gamma and RF. This V gamma and RF is nothing but your diode. This is your diode. Diode is replaced by this. This is your diode. Okay. This is the case. So P side positive, N side negative, V gamma and series with resistance. This is a complete representation of diode. Okay. Okay. Sir, sorry to interrupt. The class is going on in a super way, but now we have the network class from 8. Okay. So you are having another class. That was the reason. That's why I think class shifted to morning. Hai? Okay, no problem. We can end this class because that is also important, because you cannot take two classes simultaneously. No problem. That is genuine. Okay, that is not a problem. I can understand. Just give me a 1 minute. Okay. So this is the case. These are the three models. Okay. These are the three models. Tomorrow we will discuss the questions. No problem. Okay. Tomorrow timing is it's in morning. Okay. So those you are having the problem with the timing, I will discuss with the team if it's possible. Otherwise, I'm not guaranteeing you. Okay, or not telling anything. Okay. So meaning is that we will try to ask what is the reason. Okay, and then we will discuss this from tomorrow. Okay, no problem. Okay, tick. Okay, so we can end this class, no problem. We will continue tomorrow. From tomorrow you have to revise all these concepts that I have told you already, so that we will not having any break. Okay, in the understanding. Okay, and try to read some network concept. Okay, if network class is going on. Okay. Okay, fine. We are ending this. Okay, thank you. No problem. Okay, we will continue tomorrow. No problem. Okay.